In this video, we're going to look at naming simple alkenes and alkynes. Now, you should know from class that alkenes are compounds that have double bonds, and alkynes are compounds that have triple bonds. So naming these follows a lot of the same rules that we used for alkanes. The couple of differences we have comes into how we determine and number the chain. So when we named alkanes, we just found the longest chain of carbon atoms, whatever that was. In the case of alkenes and alkynes, we identify the longest chain, but it has to include the double or triple bond. Even if we can make a longer chain, if it doesn't contain the double or triple bond, then we don't use it. So we use the longest chain that does contain the double and triple bond. And the other thing that we do is, rather than looking at the substituents for determining how the numbering should go, we do the numbering so that the double or triple bond gets the lowest numbers. Once we've determined the longest chain and decide which end we're going to number it from, then we just name the substituents as we would for alkanes. So let's look at a couple examples. All right, so I have a double bond. So I have an alkene. So the first thing I want to do is figure out what my longest chain is. It's got to contain the double bond. So I'm going to go 1, 2, 3, 4, 5. And I don't think I can make it any longer than that. So I know that it's going to be pentene, because the end of the name of an alkene ends in ene. And I know that I'm going to start numbering from this end, because that'll give the double bond the lowest number. So the end of my name is going to be 1 pentene. And I can add the substituents to that. So my substituents are, I've got 2 methyl groups, and they're at carbons 1, 2, 3, and 4. So it's going to be 3, 4 dimethyl 1 pentene. And that would be the name of that compound. Okay, I have another alkene. I'm just in the line angle notation now. So I've got my double bond here. Finding the chain of this one is pretty easy. I've got 1, 2, 3, 4, 5, 6. So it's going to be hexene. And then I want to start numbering from this end again. And it's going to be 1, 2. So the end of my name is going to be 2 hexene. And I just have to add the substituent. And so he's on 1, 2, 3, 4, 5, 6. The bromo's on the 6th carbon. So it's going to be 6 bromo, 2 hexene. Okay. Now I have a triple bond. So it's going to be an alkyne. It looks like my longest chain is 1, 2, 3, 4, 5, 6. So it's going to be hexyne. And I guess I should make a note, right? When I have the triple bonds, it looks a little bit weird because I don't actually have angles, right? But that's because the geometry about the triple bond is going to be linear. And so this molecule is in fact linear, but I know, right, because I stop writing the lines for the triple bond here. That means that there's a carbon here and here. So it's 1, 2, 3, 4, 5, 6. So that makes it hexyne. And then the double bond starts on carbon 1, 2. So it's going to be 2, well, it's going to be 2 hexyne. And then I need to give my substituents. In this case, I have 1, 2, 3, 4. So I have a methyl group on the 4th carbon. So it's going to be 4 methyl 2 hexyne. All right, now we'll do a couple examples with cycloalkenes. If you notice, I only say cycloalkenes because I can't actually have triple bonds in cyclic compounds. It doesn't work. Carbon can't form enough bonds to do that. So we follow most of the same conventions as we did with cycloalkanes. If there are no substituents, I don't need a number. We just assume that the double bond is at carbons 1 and 2. Now, if there are substituents, then just like in the case with the straight chain ones, the double bond takes priority in determining the numbering. So the double bond is always going to be at carbons 1 and 2. And then we'll sort of go in the direction of numbering that gives the substituents the lowest numbers. But we don't need to give a number for the double bond because, again, we know the double bond's at 1 and 2. So basically, when we name cycloalkenes, we just put the double bond at 1 and 2, and then name the other substituents relative to that. All right, so here's a case. I have a hexagon, so I know that that's, in this case, because I have a double bond, it's hexene, but it's going to be cyclohexene. Now, I don't need any numbers. There are no substituents, and so all I have to do to name this is call it cyclohexene. All right, now I have another cyclic compound. This time I do have a couple of substituents. So my base name, I have 5 carbon atoms in my ring, and so that's going to be pentene, right? If it was just an alkane, it would be pentane, but because it has a double bond, it's going to be pentene. And then when I go to name the substituents, right, I'm going to get the lowest numbers if I go 1, 2, 3, 4, 5. Right? If I'd gone the other way, I'd have gone 1, 2, 3. So I'd have had 4 and 5. Instead of this way, I get 3 and 4. And so this is going to be 3 ethyl. This is going to be 4 chloro. And I do them alphabetically, just like I would with the alkanes. So this guy will come first. So it's going to be 4 chloro, 3 ethyl. Oh, and it's going to not just pentene, but it's going to be cyclopentene. So I have 4 chloro, 3 ethyl, cyclopentene.